Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi there, Herman and Corn. So in this podcast, we specialize in delving deep into the everyday things in our life that make the world tick, and sometimes the everyday things that make people go up and down buildings. Let's talk today about elevators. I mentioned my colorful rental history in Israel, from an absorption center through to sublets the first year, and then a few more places. So I've been in, I feel, more buildings than your average Jerusalemite all over the city, and plenty of them have elevators that would make your skin feel a little bit prickly as you step inside. But then you see on the side of it that they've all got this inspection certificate. So it's a twice yearly thing, but these look like something from another era. I don't know if people have been inside an elevator like the one I'm talking about. It's that mechanism where sometimes you even have these kind of crisscross grates, metal grates that come in and seal you in, and you genuinely feel like you're in a, 19th century mining shaft or something. They're kind of terrifying, but they usually work. And I say usually because I have been in a couple of nerve-wracking situations where the power went out and doors wouldn't open. So have to be honest, I'm skeptical about how rigorous the inspection regime is here. But they exist. Herman and Corn, I mentioned that my wife is an architect, and when you wonder why these things exist and why some buildings in the dilapidated state that they're in all over Israel, we have, I think, a very, very mixed housing stock. Some, multi-million luxury construction, and we've talked about the sort of social unease with that in previous episodes. And then we've got lots and lots of stock that went up shortly after the foundation of the state really quickly to house people, and besides often looking horrible, on the inside it's often shabbily and poorly built. So there's a real mixture of, I think, construction standards here. I mentioned that there's an inspection regime. I don't know exactly who does it, but every elevator has this thing attesting to somebody took a look at it, and even ones that really don't feel that safe apparently are. In the more modern buildings, the elevators they're not exactly cutting edge tech anymore, but the ones where you press a floor and it kind of decides intelligently, I guess, to minimize trips. So Herman and Corn, elevators, the more modern ones, are they more power efficient and safe than these very old looking ones? And how is it that this technology that feels like often it's barely working, and sometimes even the electrical things aren't, the lights are off, but they still, how do they manage to pass safety checks? Are they safer than they look and feel sometimes? Herman and Corn, let's talk about the things that make us go up and down tall buildings, elevators. Over to you two.
You know, Herman, there is a specific kind of adrenaline rush that you only get in certain parts of Jerusalem. It is not from the traffic or the hills, but from stepping into an elevator in a building built in the 1950s or 60s. You open that heavy manual door, then you pull back the metal accordion gate, and you just pray that the floor is actually there.
Ah, the classic Israeli elevator experience. It is a mix of mid-century industrial charm and pure, unadulterated anxiety. Herman Poppleberry here, and I know exactly what you are talking about. Our housemate Daniel actually sent us a prompt about this very thing. He has been living in various spots around the city, and he is struck by the contrast between these older, let us say, character-filled elevators and the high-tech versions you see in the new towers over in Tel Aviv or the newer parts of Jerusalem.
It is a great question because it touches on something we all interact with every day but rarely think about until we are suspended in a metal box by a few steel cables. Daniel was asking if these modern elevators are actually safer and more energy efficient than the older ones. And specifically, how on earth do those rickety, creaking boxes in older buildings manage to pass their safety inspections?
It is a fascinating look into engineering versus perception. Because, as Daniel pointed out, you see those inspection certificates, the Tazkir Bdika, taped to the wall, and they are usually up to date. In Israel, by law, a certified external inspector has to come out every 6 months to sign off on it. So, there is a formal system saying this machine is safe, even if your lizard brain is screaming that you are about to plummet into the basement.
Right, and I want to really dig into that gap between feeling safe and being safe. But before we get into the mechanics of safety, let us talk about the other part of Daniel's question, the power efficiency. Because that is where the hidden revolution in elevator technology has really happened over the last couple of decades.
Oh, absolutely. If you look at an elevator from the 1970s, you are looking at a system that is incredibly wasteful. Most of those older elevators use either a simple alternating current motor or, in some taller buildings, a direct current motor with a huge generator set. The problem with those older systems is that they are basically either on or off. When the motor starts, it draws a massive amount of current to get the car moving, and then it uses a lot of energy to hold it at the right speed.
And they use friction brakes to stop, right? So all that kinetic energy just gets turned into heat.
Exactly. It is just wasted. But modern elevators use something called variable voltage, variable frequency drives, or triple VF. This allows the motor to start slowly and ramp up, which uses much less power than that initial jolt of energy in an old system. But the real magic, corn, is regenerative braking.
This is the part that always blows my mind. It is like a hybrid car, right?
Precisely. Think about the physics here. An elevator is a counterweighted system. There is the car, and then there is a heavy weight on the other side of the pulley. Usually, that counterweight is sized to be equal to the weight of the empty car plus about 40 or 50% of its maximum capacity.
So if the car is empty and it is going up, the counterweight is actually doing the work of pulling it up.
Yes, in that scenario, the motor is actually acting as a brake to keep the car from flying up too fast. In a modern system with a regenerative drive, instead of just burning off that energy as heat, the motor acts as a generator. It takes that mechanical energy from the falling counterweight and turns it back into electricity, which it then pumps back into the building's power grid.
That is incredible. So the elevator is actually powering the hallway lights or the neighbor's refrigerator while it is moving.
In a well-optimized building, yes. You can see energy savings of 30 to 40% just from that one feature. When you combine that with more efficient permanent magnet motors, which are much smaller and more powerful than the old induction motors, the difference in power consumption between an old elevator in a 4-story building in Jerusalem and a modern one is staggering.
It makes you realize that the old ones are basically just giant space heaters that occasionally move people between floors. But let us get back to the safety aspect, because that is what really bothers people. When Daniel says he feels skeptical about the inspection regime, I think a lot of people relate to that. You see a light flickering, the floor is not quite level with the landing, and the whole thing shakes. How can an inspector look at that and say, yes, this is fine?
Well, we have to distinguish between aesthetic maintenance and structural safety. An elevator inspector in Israel is looking at very specific, heavy-duty safety systems that are designed to be fail-safe. The most important one, and the reason why elevators are actually one of the safest forms of travel, is the governor and the safety gear.
This goes back to Elisha Otis, right? The famous demonstration in 1854 where he cut the rope?
Exactly. That is the foundational moment of the modern city. Without that safety, we would not have skyscrapers. The way it works is actually quite elegant and entirely mechanical. There is a separate cable called the governor rope that moves with the elevator. If the elevator starts moving too fast, even by a small percentage over its rated speed, centrifugal force causes a set of weighted flyballs in the governor to swing out and trip a mechanical switch.
And that happens even if the power is out.
Yes, it is purely mechanical. Once that switch is tripped, it grabs the governor rope. Since the rope is now stuck and the elevator is still moving, the rope pulls a lever on the car itself. That lever engages the safety gears, which are basically heavy-duty steel wedges or rollers that bite into the guide rails. They literally clamp the car to the steel tracks that it runs on. It is an incredibly violent stop, but the car is not going anywhere.
So when Daniel is in one of those old elevators and he is worried about the cable snapping, the reality is that even if the main hoisting cables failed, which is extremely rare because they are over-engineered by a factor of about 12, these mechanical safeties would still catch the car.
Right. And those are the things the inspector is testing. They check the tension on the cables, they check the wear on the grooves of the drive sheave, and they often perform a test where they actually trip the safeties to make sure they bite. An elevator can look like a total wreck, the buttons can be missing, and the interior can be scratched up. But if those mechanical clamps work and the cables are sound, it passes the safety check.
That makes sense. But what about the doors? In those older buildings, you have that manual outer door and then the inner gate. I've seen cases where you can actually open the outer door even if the elevator is not there. That feels like a massive safety hole.
That is actually one of the most common causes of elevator accidents, and it is something inspectors are supposed to be very strict about. It is called the door interlock system. There is a mechanical and electrical lock on every floor. The elevator car has a little cam or a ramp that pushes a lever on the door lock when it arrives at the floor. If that interlock is bypassed or broken, it is a major violation.
I wonder if some of the skepticism Daniel feels comes from the fact that in older buildings, maintenance is often reactive rather than proactive. If the building committee is trying to save money, they might only fix things when they actually break.
That is definitely part of it. And there is also the issue of leveling. You know how sometimes you step out and the elevator is 2 inches higher or lower than the floor? That is a huge trip hazard. Modern elevators use sophisticated sensors and software to ensure the car stops exactly level every time. Older ones rely on mechanical switches and brakes that can go out of adjustment as they wear down or as the temperature changes.
So, while the old elevator might not fall down the shaft, it might still trip you or trap you. Daniel mentioned being in situations where the power went out and the doors would not open. That is a terrifying experience, even if you are technically safe.
It is, and that is another area where modern technology has made huge strides. Most modern elevators are equipped with an automatic rescue device, or ARD. It is basically a battery backup system. If the power goes out, the ARD kicks in, moves the elevator to the nearest floor, and opens the doors. It is not meant to keep the elevator running for hours, just to make sure no one gets trapped.
That seems like it should be mandatory everywhere. Is it common in older buildings in Israel to retrofit those?
It is becoming more common, and for new installations in Israel, it has been mandatory for years under Israeli Standard 24. A lot of the older buildings in Jerusalem are managed by small housing committees, the Vaad Bayit, and they often struggle to fund major upgrades. But you are seeing more regulations coming in that require certain safety updates over time.
Let us talk about the brain of the elevator for a second. Daniel mentioned those smart systems where you press the floor number on a screen outside the elevator instead of inside. That is called destination dispatch, right?
Yes, and it is a fascinating piece of optimization. In a traditional system, you press a button to go up, an elevator arrives, you get in, and then you press your floor. The elevator just reacts to whoever pressed the button first. It is very inefficient because you might have 5 people going to 5 different floors, and the elevator is stopping at every single one.
And meanwhile, another elevator is doing the exact same thing right next to it.
Exactly. With destination dispatch, the system knows exactly where everyone wants to go before they even step into a car. It uses an algorithm to group people going to the same floors into the same elevator. This reduces the number of stops, which saves a massive amount of energy and also reduces wait times. It turns the elevator bank into a coordinated fleet rather than a bunch of individual cars.
It is like ride-sharing for vertical transport, but it can be confusing for people the first time they use it. You get into the elevator, and there are no buttons. You just have to trust that the machine remembered where you wanted to go.
It is a big shift in user experience. But from an efficiency standpoint, it is a game changer. For a high-rise building, it can increase the handling capacity by 30% or more without adding any more elevators.
I want to go back to the Israeli context that Daniel brought up. He mentioned the difference in housing stock from the older buildings put up quickly after the state was founded to the luxury towers today. There is a real sense of a two-tier system in terms of infrastructure maintenance.
There really is. And it is not just about the elevators themselves, but the whole building's electrical system. A lot of those older buildings have outdated wiring that was never designed for the load of modern appliances, let alone a high-efficiency elevator drive. Sometimes the shabbiness that Daniel feels is a symptom of the building's overall age and the difficulty of keeping up with modern standards.
It is interesting because Israel actually has some of the strictest elevator codes in the world, partly because of the high density of apartment living. The Standards Institution of Israel, or Mashon HaTkanim, has very specific requirements for everything from the strength of the cables to the fire rating of the doors.
That is a great point. Even if an elevator looks like it belongs in a black and white movie, it still has to meet those baseline standards to get that certificate. The inspector is a third party, usually from a certified private firm authorized by the Ministry of Labor, so they do not have a vested interest in passing a dangerous elevator. If they sign off on it, the core safety systems are almost certainly functional.
So, to answer Daniel's question directly, yes, modern elevators are significantly more power efficient. They are smarter in how they move people. And while they are safer in terms of things like leveling and door sensors, the older elevators are actually much safer than they look because the fundamental mechanical safeties have not changed that much in 100 years.
Right. The physics of catching a falling box are pretty much solved. The improvements have been in the soft safety areas, things like light curtains that detect your hand in the door before it hits you, or sensors that can tell if a cable is starting to fray before it actually becomes a problem.
I think there is also a psychological element here. An old elevator is loud. You hear the relays clicking, you hear the motor humming, you feel the vibration of the guide rails. A modern elevator is nearly silent. We tend to associate noise and vibration with danger, even if the machine is perfectly healthy.
That is so true. It is like an old car versus a new electric car. The old car feels like it is working harder because you can hear the explosions in the engine, but the electric car is actually more powerful and more reliable. In an elevator, that silence is the result of precision engineering, better lubrication, and digital control systems that smooth out every movement.
You mentioned the Shabbat elevator earlier when we were talking before the show. That is a uniquely Israeli thing that has a huge impact on energy efficiency and wear and tear, right?
Oh, definitely. For those who do not know, a Shabbat elevator is programmed to stop at every floor automatically so that observant Jews do not have to perform the work of pressing a button on the Sabbath. From an engineering perspective, it is the worst possible way to run an elevator.
It is the opposite of destination dispatch.
Literally the opposite. It is stopping and starting constantly, which is when the motor uses the most power and the brakes get the most wear. Modern Shabbat elevators are much better at this because they use those regenerative drives we talked about. They can recapture some of that energy as they decelerate at every floor, but it still puts a lot of cycles on the equipment.
I wonder if that is why some of those older elevators in Jerusalem feel so worn out. If they've been running in Shabbat mode every weekend for 40 years, that is a lot of extra mileage on the motor and the door operators.
That is a very astute observation, Corn. The door operator is usually the first thing to fail on an elevator because it has the most moving parts and it gets cycled more than anything else. In Shabbat mode, those doors are opening and closing on every floor, whether someone is there or not. It is a lot of mechanical stress.
So, if you were Daniel and you were looking at that inspection certificate, you can take some comfort in the fact that the falling down the shaft scenario is extremely unlikely. But you should probably still keep your phone handy in case the door operator decides to give up the ghost between floors.
Exactly. And maybe check the leveling before you step out. But really, the transition from the old traction elevators to modern MRL systems, that is, machine room-less elevators, is what is changing the landscape.
Wait, machine room less? Where does the motor go?
It is tucked right into the top of the hoistway. Because the modern permanent magnet motors are so small and efficient, you do not need that big concrete room on the roof anymore. It saves space, it is easier to maintain, and it is much quieter for the people living on the top floor.
That is a huge benefit for architects. I can see why Daniel's wife, being an architect, would be interested in this. It changes the whole profile of a building.
It really does. It allows for cleaner roof lines and more usable space. And when you combine that with the energy savings, it is easy to see why developers are moving away from the old styles. But for those of us living in the older parts of the city, those old traction elevators are going to be with us for a long time. They were built to last, and as long as they are maintained, they will keep chugging along.
It is a bit like the old Mercedes taxis you still see in some parts of the world. They might be noisy, and the interior might be held together with duct tape, but the engine will probably outlast us all.
That is a perfect analogy. There is a certain ruggedness to those old mechanical systems. They do not have microprocessors that can be fried by a power surge. They just have heavy-duty copper coils and steel levers.
I think we have covered a lot of ground here, from the physics of the governor to the economics of regenerative braking. It is amazing how much technology is packed into such a small space.
It really is. And it is a great reminder that even the most mundane things in our lives, the things we take for granted every day, are often the result of incredible engineering and decades of safety evolution.
Well, before we wrap up, I want to remind everyone that if you have a question or a topic you want us to dive into, just like Daniel did, you can reach out to us. We love getting these prompts that make us look at our surroundings in a new way.
Absolutely. You can find the contact form on our website at myweirdprompts.com. We also have a searchable archive there if you want to check out our past discussions on everything from urban planning to the science of habit.
And if you are enjoying the show, we would really appreciate it if you could leave us a review on Spotify or whatever podcast app you use. It genuinely helps other curious people find the show.
It really does. A quick rating or a few words in a review makes a world of difference for an independent show like ours.
So, next time you are in an old elevator in Jerusalem, Daniel, just remember, the physics are on your side. Even if the gate is rusty, those steel wedges are ready to catch you.
Just maybe do not jump around too much in there.
Good advice, Herman. This has been My Weird Prompts. I am Corn.
And I am Herman Poppleberry. Thanks for listening.
We will see you next time as we continue to explore the fascinating, the technical, and the just plain weird things that make our world work.
Until then, keep asking those questions.
All right, let us go see if the elevator in our building is actually working today, or if we are taking the stairs.
I could use the exercise anyway. Those Jerusalem hills are no joke.
Fair point. Thanks for listening, everyone.
Goodbye.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.